Which one of the following is a criterion in the design of hydrodynamic journal bearing? Option A, Sommerfeld number. Option B, rating life. Option C, specific dynamic capacity. Option D, rotation factor. So rating life, specific dynamic capacity and rotation factor all belong to the roller bearing or ball bearing. So Sommerfeld number is a criterion to design the hydrodynamic journal bearing. So option A is correct. So the answer is Sommerfeld number, answer A. Second question, a journal bearing sustains a radial load of 3672 Newton. The diameter of the bearing is 50 mm and the length is 0.1 meter. So the value of Sommerfeld number is asked. The Sommerfeld number is Zn dash by P into d by c the whole square. So Z is absolute viscosity. You have to substitute the value as 0.06 kg per meter per second, and n dash is speed in RPS. So speed in RPM is given as 500 RPM. So 500 by 60 is a n dash. Then P is the pressure. So P equal to W by L into D. That is the bearing pressure equal to bearing pressure P equal to W by L into D. So W is given, load is 3672, L is given, length is 0.1 meter and D is 50 mm. So you can substitute the value P, and diameter is 50 mm, diameter of the bearing is 50 mm and the diametral clearance is 0.1 mm. If you substitute, you can get the answer 10.3 into 10 power 6. So answer is B. So Sommerfeld number is Zn dash by P into d by c the whole square. This is a formula for Sommerfeld number. Which of the following bearings have a low starting friction? That is hydrodynamic bearing. It is called as journal bearing, hydrostatic bearing, a ball bearing and roller bearing. So ball bearing have a very low starting friction. It has a coefficient of friction of the order 0.001 mm. So option C is correct. Ball bearing. Bearings are generally classified into two categories. One is sliding contact bearing and rolling contact bearing. In sliding contact bearing, that is, it is called as journal bearing. Rolling contact bearing is called as, and there is example for rolling contact bearings are ball bearing, roller bearing, needle bearing. All are the examples for rolling contact bearings. Rollers are small sliding objects, are balls or rollers are placed in between the bearing surfaces. So it is called as rolling contact bearing. In sliding contact bearing, in the bearing area, so the journal is heavy, highly loaded or heavy weight journal is present in between the bearing. Okay, in rest, so the inside smaller circle is called as a journal, okay, or shaft, and outer circle is called as a bearing. So in between the shaft and the bearing, oil is filled. Okay, in rest, at rest, the journal and the bearing have metal to metal contact. At slow speed, okay, at slow speed, still there is a metal to metal contact between the shaft and the bearing. Okay, the shaft rotates in case of hydrodynamic bearings. So at high speed, due to the rotation of the journal, a thin film of lubrication is formed. A thin film of lubrication is formed, and this is called as, and it is called as wedge action. Okay, there is no metal to metal contact in case of hydrodynamic journal bearings. Okay, initially there will be metal to metal contact, but at high speeds, when the journal rotates, a thin film of lubrication is formed in between the journal and the bearing. Okay, an example for hydrodynamic journal bearing is crankshaft. In automobiles, crankshaft, and the crankshaft is an example for the hydrodynamic journal bearing. It is a highly heavy loaded shaft. Okay, a thin film of lubrication is formed, and this action is called as wedge action. Okay, so the here but hydrodynamic bearing, so they can be used for very heavy loads. Hydrostatic bearings, the journal will not rotate, shaft will not rotate. Ball bearing have low coefficient of friction. What is the main advantage of hydrodynamic bearing over roller bearing? Okay, option C is correct. It has superior load carrying capacity at higher speeds. Okay, the roller bearing or ball bearing cannot be used for heavy loads, but hydrodynamic bearings can be used for heavy loads. Okay, so superior load carrying capacity at higher speeds can be possible using hydrodynamic journal bearing. Okay, option C is correct. Okay, it is classified into full journal bearing. If it is of 360 degree, it is called as full journal bearing. 120 degree partial journal bearing. 120 degree filled journal bearing. Okay, in full journal bearing, angle of contact of the bearing with the journal is 360 degree. Okay, in full journal bearing, angle of contact of the bearings with the journal is 360 degree. Option C is correct. In hydrodynamic bearings, that is the oil film is maintained by supplying oil under pressure. The oil film pressure is generated only by the rotation of the journal. Okay, so we are not maintaining the oil pressure, we are not giving any external pressure on the journal or shaft, but the oil film pressure is generated by the rotation of the journal. When the journal rotates, an oil film pressure is generated and there is no metal to metal contact takes place. So the C, diagram C, so oil film pressure is generated and there is metal to metal contact take place. No metal to metal contact take place. So it is by the only by the rotation of the journal. So option B is correct. Okay, it is not by external supply of lubricant or it is not by grease. It is by the rotation of the journal oil film pressure is generated in the hydrodynamic bearings. In sliding contact bearings, a positive pressure is built up and a load supported by the fluid only by the use of a, option C, converging film. Okay, the film is a converging film. Okay, it is converging. The oil film is starts converging. Okay, converging film. Option C is correct. It is by the converging film. The bearing which can support steady loads without any relative motion between the journal and bearing is called as hydrostatic bearings. Okay, see the fourth one, hydrostatic bearings. In hydrostatic bearings, it can support steady loads without any relative motion between the journal and the bearing. Okay, it will not, the journal will not rotate, journal or shaft will not rotate in case of hydrostatic bearing. Only it supports a load, so it is called as a hydrostatic bearing. Bearing which can support steady loads without any relative motion between the journal and bearing is called as hydrostatic bearings. Next one, if Z is absolute viscosity of lubricant, N is a speed and P bearing pressure, then the bearing characteristics number is Zn by P. Zn by P. So option A is correct. Okay, Zn by P is a bearing characteristics number, Zn by P. In thick film hydrodynamic journal bearings, the coefficient of friction first decrease then increase. Okay, in the coefficient of friction, so coefficient of friction is plotted along y-axis, Zn by P is plotted along x-axis. Coefficient of friction first decreases, then starts increasing. So first decreases with increases in load. Okay, so option C is correct. It will not increase, it is decreasing with the increase in load. Okay, option C is correct. So in this, and at A, bearing characteristics number Zn by P is called as a bearing modulus. So the minimum moment of friction occurs at A, and at this point the value of Zn by P is known as bearing modulus. Okay, and is denoted by K. Okay. Now when the bearing is subjected to large fluctuations of load and heavy impacts, the bearing characteristics number should be 15 times the bearing modulus. Okay, 15 times the bearing modulus. Okay, the bearing modulus is 15 times the bearing characteristics number. Okay, so bearing modulus, so this is Z along the x-axis, it is Zn by P. It depends on viscosity and speed as well as the pressure. Okay, so this at point A it is called as bearing modulus. So bearing subject to large fluctuations of load, bearing characteristics number should be 15 times the bearing modulus. Okay, the bearing characteristics number is defined as Zn by P. Option A is correct. Then heat generated in the journal bearing is termed as mu W into V. mu is a coefficient of friction, W is a load, V is a surface velocity. Okay, velocity of the journal. V equal to pi d n by 60. So option D is correct. Mu W into V. Mu is coefficient of friction, W load, and V is a velocity. Mu into W into V. Okay, heat dissipated is C into A TB minus TA. Okay, C is heat dissipation coefficient, A is a surface area, and TB is a temperature of bearing surface, and TA is a ambient temperature. So heat generated and heat dissipated, it is going out of the bearing, is heat dissipated. In the journal bearing, the radius of the friction circle increases with the increase in radius of the journal. Option B is correct. Radius of friction circle increases with the increase of radius of the journal. Option B is correct. The bearing characteristics number depends upon, so it is bearing characteristics number is Zn by P. Okay, it depends upon P is nothing but P equal to W by LD. W by L into D. Bearing pressure equal to W by L into D. So W equal to bearing load. It depends upon bearing load, and L in D, and this is the P. Okay, it is Zn by P. So option D is correct. Okay, so P equal to W by LD. So option D is correct. A thick lubrication is a stable, option A stable lubrication because there is no metal to metal contact. A thick lubrication and a thin lubrication is an unstable lubrication. Thick lubrication is a stable lubrication because there is no metal to metal contact occurs between the journal and the bearing. Okay, it is a stable lubrication. Okay, next, in the hydrodynamic channel bearings, the clearance ratio is halved. Then the Sommerfeld number S and the coefficient of friction mu will changes. We know that Sommerfeld number equal to S equal to Zn dash by P into D by C the whole square. Zn by P is bearing characteristics number. Zn dash by P here. N dash is Z is absolute viscosity. N dash is speed in RPS. So that is, if it is 500 RPM, it is 500 by 60. P is the pressure. P equal to W by L into D. And D is the diameter, and C is the clearance. Diametral clearance. Okay, capital C for diametral clearance, the whole square. Okay, if the clearance ratio is halved, okay, if C equal to 1 by 2, okay, if C becomes halved 1 by 2, so 1 by 2 the whole square is, so 1 by 2 it will go up. Okay, if D by C it will go up, so it will become 4 times. S becomes 4 times because C equal to C by 2. Okay, C by 2 the whole square. So in the denominator becomes numerator. Okay, C equal to C by 2, denominator becomes numerator, it becomes 4 times. S becomes 4 times. And Mickey's equation is, so it is, Mickey's equation describes a coefficient of friction. So coefficient of friction is always less than 1. Coefficient of friction mu equal to 33.25 into 10 divided by 10 power 10 into Zn by P into D by C plus K. K equal to 0.001 constant. Okay, so D by C, C here D by C. So C equal to C by 2. So denominator is numerator. So it becomes 2. So Mickey's that is coefficient of friction becomes doubled. Okay, S becomes 4 times, mu is doubled. Okay, thank you.